Good morning, fine students of the Excel Center. Welcome to Chemistry Week 6. All right, so today I put up the worksheet. Hopefully by the time I'm recording this, you haven't tried to do it yet, but if so, kudos to you. You do need to, and I do recommend that you first read the CK12 reading. That's going to be pretty important, and last week's lessons generally understanding, because I'm going to use that terminology as we go through balancing equations. What is balancing equations like? It's like having a grill out or a party, right? And you go to the store, and you're going to invite some friends over, so you get a pack of cheese and 24 slice, right? And you get a couple packs of buns, and that comes out to about 20. And you tell your kid, go get the hamburger. Not that you trust your kid with getting a hamburger, but for the sake of the analogy, you'll see. And they come back with a pack, and there's 8 patties in there. How many people are going to be at your party are going to get a cheeseburger? Well, 24, right? You have 24 slices of cheese. Well, from that, it sounds like 4 people are going to get nothing but cheese. 20 people will get at least a bun with their cheese, and only 8 people will really get a cheeseburger, right? And so the burger patties are what we call the limiting reagent. That's the limiting reactant. Why is it a limiting reactant? Well, there's only 8 of them. The cheeseburger making process stops with the last patty. You're going to have excess bread and even more excess cheese. Okay. In chemistry, we can't do that, right? We have to be able to account for everything that's going to be in the chemical reaction. It has to be balanced. We got to have 14 patties for the 14 buns with 14 slices of cheese with no excess. All right, it's got to be balanced, and that's what we're going to do today. All right, we're going to learn how to balance these chemical reactions so that on each side of the arrow, it's the same. So going to the classroom, classwork, we are on week 6, chemical equations. The assignment I'm doing a video for is this one. First, you want to go through balancing chemical equations, and I recommend that you watch the 2 videos, or at least one of them before. So again, you'll click on that, and just as before, if you're able to, I know not everyone's able to open with Kami. This will allow you to mark on it. Happy teacher. Oh, look at that. Who did that? Teacher. That was fun. I did not know. Okay, so here they are. I'm going to work through one example for you. Actually, I'm going to work through 2 because number 2 is just a little difficult. Or I'll give you a head start on number 2, but let's do number 1. All right, we could pretend kind of that this, the burgers, cheese, patties, and so forth. And we need to make sure that there's the same amount on each side. Okay, so this is Fe is iron, hydrogen, SO4 is a unit. We can tell because over here it has parentheses around it, and it looks like it stays together. So what we want is the same number of atoms on each side of the equation. And what this is what we're trying to maintain here and obey is the law of conservation. It's a law of conservation, in this case, of matter or of mass, okay? Law of conservation of mass. This is used in a number of ways. So if we have, like I can see here already, on the right-hand side of the arrow, the product side, that I have 3, okay, of these, whoops, let me get my other tool, that I have 3 of these SO4s. And over here, I only have 1 SO4. So automatically, I can see right now, I'm going to need to add to this side because there's 3 there. I need 3 over here. All right, so I'm just doing some preliminary. That's what you're going to have to do. It takes a little bit for each of these. Iron, I can see there's 2 FEs. There's only 1 Fe over here. So I'm going to need to add a number 2 over here. Now, if it were that easy, we'll go ahead and start, and be prepared to go through this a few times. I'm going to erase my little lines here. All right. So now I have 2 irons, 3 SO4s, 3 SO4s. So what would this be in this blank? Well, so far it looks like that's balanced. So I'm going to go ahead and put my 1 there for now. So I have 2 iron, 3 SO4s, and 3 SO4s. I look balanced. However, when we change this 3 over here, that means we also have 3 H2s for a total of 6 hydrogen. Well, in this case, it's not too bad because over here I do have a space with H2. So if we know that there's supposed to be 6 hydrogen on this side of the equation in the reactants, what would make H2 to have 6? And you can do that math, that would be 3. Okay. And that's how you do it. Whenever you have a single element like H2 is over here, that's kind of probably the last one you want to fill in, because you can always add whatever number after you get these other more difficult ones in. You work with the difficult ones first, typically, or follow the steps in the video, and you'll see it comes out the same way. Okay, so that's it. This one is balanced. Okay. And as I want to go back through again, 2 iron. I see over here 1 molecule of iron sulfide, so that's 2 iron for that, so that's balanced. 3 times 2 hydrogen is 6 hydrogen, and over here I have 6 hydrogen. I have 3 SO4s in this molecule, and over here I have 3 SO4s in this molecule. So number 1 is done. Okay, and that's the answer. I'll work the next one for you as an example one more time, because this particular one is more difficult than the others. We don't get to really high numbers. They're usually between like 1 and 4. You don't often, but they can be more. So I'm going to look here. I see I have kind of a free agent, oxygen. So I'm going to leave that one alone. Okay. Why? Because if it turns out due to this mixing up that I need more. So let's look at the kind of reaction this is. This reaction, we have an C2H6 plus some amount of oxygen is going to yield or produce water and carbon dioxide. Okay, so we have water and carbon dioxide on the products, and then we have C2H6, a hydrocarbon, with oxygen on the left side, or what we call the reactants. So I have H2O, and usually I'll have scratch sheet of paper. Let's see, it doesn't let me write over there. Scratch sheet of paper and rewrite these on paper, and I'll make a list. And the way I do it is because of handwriting, I'm going to go ahead and make a text box here just to show y'all real quick. I will put my carbon, hydrogen, oxygen. Those look like the 3 elements that we're using, correct? Do you see anything else on either side of this? No, I do not. And what I'll do is I'll write my initial number of molecules. So I'm going to make this real thin. So on this side, carbon, I see 2 carbon over here, and I see 1 carbon. Hydrogen, I see 6, and over here, I just see 2. And then oxygen over here, I see 2, and over here, I see 3. So I usually, underneath the arrow, if I was doing this on my own paper, sorry to get so close to the camera there, I would just put those accounting. So clearly, I have more mass, more elements on the left-hand side of the reactants. I need to account for those in the product side, okay? So if I added 1 carbon, the only way to do it is over here. I would have to add an extra 1, so I'd say 2. So now I can say this is 2, and we're good. We have the same on each side. But that also changed the oxygen number to 4. So 4 plus the 1 is 5. So I'm going to draw a line through that and write 5. Now, the hydrogen is still 2 and O, but we need more hydrogen over here. It looks like we need to have a total of 6, and there's 2. So if I multiply that by 3, 3 times 2 is 6, and then we have our 6 hydrogen. So far carbon's good and hydrogen is good. The oxygen is off. Trust me, we're not done yet. Actually, we're gonna have to change some of these. So it's good if you do these in pencil. All right, so we have 2, it seemed to be done now that we've done those. But when we come over here, so let's see, carbon 2, yep. Carbon 2, yes. We have hydrogen 6, yep. Hydrogen 6, and 3 times 2 is 6, yes. Oxygen 2, oxygen over here, 2 times 4, 2 times 2 is 4, plus the 1 is 5. How are we going to get a 2 to a 5 when we cannot change, if you recall, we cannot change the coefficients. We can only add, I'm sorry, we cannot add this, change the subscript. We can only change the coefficients, okay? Well, we're clearly not going to be able to make that oxygen a 5. The best we can do is add another one, and that would make it 4. It still wouldn't be enough, so we're going to have to make it a 3 for now, possibly. And when we do the 3 times 2, that makes this a 6. But now we have 1 less over here. Now we can change this 2 to, for the carbon dioxide to a 3, or we can change the water in order to work with that oxygen. Which one do you want to change? Okay. So when I look at I see 2 carbon, that's 4 carbon. It changes the oxygen to 4 oxygen over here. And so I'm going to have, and I have 6 oxygen here now, it has to be. But how do we get this back up, the 5? Because now this 5, this over here has to be equal. Hold on, I'm competing with meetings. Okay, sorry about that. So what I did is I just quickly erased. If you want to rewind this even 10 seconds, you'll see that all I did right here was clean it up a little bit. I just erased the markings. And so I've brought in the new numbers are up to date. So where we left off is right here. We have 7 oxygen and 6 oxygen. Clearly we can't just keep bumping up one. I mean, we can, but that's the long way to do it. We got to have an even number. There's no one way. When we have a diatomic gas like oxygen, increasing it 1 time makes this number increase 2 times, right? So we're going to have to think of a new strategy. So you sit back, look at it, think about it. Balancing equations is simple, but it's not without some thought. You're going to have to put some thought into this as you go through. It's fun. If you like Sudoku and little puzzles, this is the way you should probably view this as a little puzzle. So the best way to do this to get these back up, and I'm going to go ahead and remind myself that, okay, well, I don't want to be changing and making everything dependent on this oxygen here, because that's my free agent, right? I mean, he's just alone. So in the end, if I needed to, I could always put whatever number I need to make that, to make it work. So we're going to leave that blank for now. What I am going to do, though, and see is that because I'm going to need more oxygen over here, I can't just bump it by 1, because bumping it by another one, 4 times 2, that becomes 8. Now I'm 1 above, and you come back over here. It's not going to help my oxygen. I can tell you where you'll end up, and you will end up at the answer, but you can go back and forth and back and forth. What I'm going to do instead is over here, we can make a big difference just by even saying what we have there, 2, and that made it 2. But if we make this a 4, because that's the only way to increase this number over here, we have our 4 carbon dioxide. So when we do this, and this is where you kind of sit back and do some thinking, when you look at your numbers, and you see you're going to have to increase by 2. So you have 8 now oxygen. I'm going to erase my 7. And now I have 8 oxygen. And it's going to be 8 plus whatever I have over here. Right? And right now it's 3, but we're not done here. So I'm going to have to erase this. Why am I erasing the 3? Well, because when I increased carbon, okay, to 4, I'm going to have to make this a 2. So now the carbon is balanced again. And how much carbon do we have? We have 4 on this side, and we have 4 on this side. And what else changed when we changed it? Hydrogen. 2 times 6 is 12. So now we have 12 hydrogen on this side. Do notice that it's H2. So if we needed 6 more hydrogen, I just put a 6 right here, right? So now 6 times 2 is 12. So I have 12 hydrogen on each side. So just looking at this first reactant, C2H6, we have 2 times C2 is 4 carbon, and 2 times 6 is 12 hydrogen. Oxygen is a free agent. So I'm going to say for now, we're going to erase that. If I have 6 water molecules, 6 times 2 hydrogen is 12, so that's okay. This one looks like it all checks out. And 6 oxygen. 6 oxygen, and what do I have over here? 8 oxygen. So 6 plus 8 is 14. Now, the only thing we're missing is how many oxygen. What can we do with this number? What coefficient would make oxygen come out to 14? 7. Okay, 7 times 2 is 14. I'm going to erase those lines. And now 14. Again, this would be like on scratch paper. So 4 and 4, check. 12 and 12, check. 14, 14, check. And we are balanced. So if I had to clean this up a little bit, that's on my scratch paper. This would be the answer. Now that's a tough one, like I said. So I wanted to do that one for you because that one would have drove you nuts on number 2 and you would have been totally discouraged. The rest of them are not so hard. I am going to point out one thing though, and that is there are these clusters of atoms that occur together. You don't have to know the name of them or charge, but notice that they happen together. And the bottom line is the bottom line. Just like I made C, H, and O up here, you just want to keep the element number. But it might help you to know that certain of these stay together when they're in chemical reactions, such as PO4. Okay, you can see they're grouped. So observation is going to be key here. These look like a total rearrangement on number 4, total rearrangement on number 5. Number 6, I can see that there's a CO3 and a CO3, an NO3 and an NO3. So that tells me what? It tells me those stay together. This NO3 and the CO3 stay together. It's carbonate and nitrate, actually. Number 7, we see NO3 again as a cluster. We call those polyatomic ions. You don't have to memorize that name. All it means is many atoms in the ion. More than one, actually, is all it means in this case. So SO3, SO3, here's another NO3 and an NH4, and a PO4. Here's an NO3, NH4, and a PO4. So those are clusters that stay together. It kind of actually makes it easier, but I'm not going to go into why I think in doing them, you'll see why it makes it easier. Do the best you can. I'm not going to grade this stringently. I will give you the answers by tomorrow morning. I'll post them and you can check yourself. Okay. So this is all we're doing today. This would probably take 45 minutes of class time to get through. So be friendly and patient with yourself. I did not answer probably every question in this. It's hard to predict the questions. Of course, when I talk about this, I talk about it through my own perspective. But follow the steps. If you watch the video, there's a step-by-step way to solve these. I just kind of went about it in a logical way, so not too difficult. They can get pretty difficult. This is first level. All right. Hope that helped.